Hi, this is Ken Taylor. My Raspberry Pi hack is a behavioral sleep study lab. As background, my son Clifford has been having sleep issues for well over a year. Unfortunately, traditional sleep labs, whether they be on-premise or at home, have been unsuccessful for him. He's been unable to participate in those because of his developmental disability. And I'm willing to believe that this is a problem for most people in the developmentally disabled community. What's required here is a way for his medical professionals to assess the behavioral patterns of his sleep in a completely no-touch environment. The sleep lab hardware environment consists of the Raspberry Pi, a wireless USB adapter that you see right there, this little Logitech C905 USB webcam that I had lying about the house, and a helper tool, and that's going to hold the webcam in place. Core software that I'm using is a package called Motion for motion capture, and some custom Ruby code for audio capture that makes the motion and audio behave in a similar fashion for both snippet rendering and metadata logging. Now let's go into the IoT lab and see how things are progressing. One of the features of this system is that I can view in real time what's going on. Via the Lighty web server, I can view what the webcam is seeing. I can see Clifford in his bed. I can see that the motion software is working. I can see some occasional movements on Clifford's part. And I can sense that the overall system is working and that I'm not wasting my time overnight. I can also go over here to PHP PG admin, and I can see that Postgres is logging events. So even though Clifford right now is not making any vocalizations, I can see that Postgres is logging motion events. And I can see that since I've started the event monitoring, Postgres has already logged 4 motion events for me to study, or for the specialists to study later on. So I know that things are happening, the system is working as it's supposed to be working, and I can go to sleep knowing that the system is doing a correct sleep study. Now that the sleep study has completed, you can see that there are very many events during the night that have been captured here in the Postgres database. So what I can do here is take all of these time-stamped events and export them into Excel. I also want to be able to copy all of the video and audio files that were created during the night back from the Pi onto my PC. The reason I want to be able to do that is so that I can package them all up onto the DVD or CD that I'm going to press for the medical professionals and create an overall package of both audio and video files, as well as the charts that I'm going to produce from the metadata that was produced. In order to get the audio and video clips back from the Pi onto my PC, I use a program called FileZilla, which is an FTP program that interacts very well with the FTP server that's running on the Pi. Now that all of the data has been uploaded from the Pi, I can begin to do some basic analytics. We can see here that the greatest number of combined vocal and movement issues are occurring between the hours of 10:30 and 11:40 on this particular evening. What I'm going to want to do next is take a look at least one of the combined data points and inspect both the audio and video to see what's actually going on at that time. Let's first take a look at the video file, and we can see here that Cliff is quite restless. He seems to be saying something. His ear seems to be bothering him, and again, he's quite restless in this video. Now let's see what the noise capture program was recording during that time.
No. No.
We can hear that Cliff was clearly having some issues and that the vocalizations lined up with the movements that we saw during that sample. So that's it, a complete behavioral sleep study delivered on a DVD to the pros who will hopefully analyze the data.